everyone, welcome back. So you've heard me say before that you need to have a plan for your program before you sit down at the keyboard. But what should our plan include, and how do we really go about starting that process? Well, today, you and I are going to have a planning party. I'm going to show you 2 important steps that you always need to do before writing a program. The first is preparing any formulas that you're going to need. By breaking those down ahead of time, you're able to see if there's anything that you're going to need to collect from the user, and at the end, you're going to have a big head start on knowing all of your variables. The second is creating a flowchart, and that's going to organize the flow of your program from start to finish. If you've never used a flowchart before, the point of it is to demonstrate a process or a function in a visual way. It's also worth noting at this point that flowcharts are such a critical part of the planning process that a lot of tech companies require you to do one as part of your interview. They put you up in front of a whiteboard, they say, here's our program idea, make us a flowchart. And then they sit there and hawk you while you do it. Yeah, talk about nerve-wracking. Unless, of course, you do this video with me. And then, for all of your future programs. At which point, flowcharting is going to be second nature for you, and you have nothing to worry about. I promise this is going to be a lot of fun. And if you develop these habits now, you and your future employers are going to thank me. Let's party. Since a flowchart is supposed to be a visual representation of your program, this means that just by looking at it, someone should be able to tell what your program does, the steps taken to make that happen, and the order in which the steps occur. So here we have a nice example. Take a minute to look it over while I explain a couple things. First, we have a distinct start and end to our program. All right. And then between them, we have some different shapes. Now, here's all of the shapes that you might find in a flowchart. And as you can see by the labels, each shape indicates a different type of action in our program. So in our example, we have parallelograms, which represent our input and output as a trapezoid. Here, this is going to indicate a decision or a split in the flow of our program, our diamond. Kind of like a choose your own adventure book. Did anyone read Goosebumps as a kid? Anybody? Anybody? Okay. So our shapes tell us something about our program, but the way that they're connected does too. So the arrows are being used to indicate the flow between these different steps. So let's take a look at this flowchart and see if we can figure out what this program does. Following the arrow from start, our first step here is a parallelogram. We know this should be an input or an output. Inside it says input num1. So it sounds like we're going to be initializing a variable called num1 using our cin command. Now let's pretend that we were running this as we go so we can play along. Let's say that I initialize num1 to 5. All right. Next, we have an input for num2. So this one, let's do 9. Okay. So far, we know that this program is going to collect 2 numbers from the user. Next, we have our diamond, which is going to represent a decision. To see the condition of the decision, we look at what's written inside. So this says num1 greater than num2, and then we have 2 arrows coming off, one for true and one for false. Right now, num1 is 5 and num2 is 9. So would you say that this condition, num1 greater than num1 is greater than num2? No, it's not, it's false, right? So we follow the false arrow, we come down here, and this says display num2. Now, what if we had some different values here? Let's say I just flipped them. And we get to this condition. So num1 greater than num2. Since 9 is greater than 5, this condition is now true. And we come over here and we display num1. So either way we go from our decision, we display value, and then our program stops. Let's read this evaluation statement carefully just one more time. And pro tip, when you're working this stuff out, talk aloud. It helps so much. So in English, this statement says, if num1 is greater than num2, display num1. If it's false, which means that num2 is the larger number, display num2. Do you see a theme here? If num1 is the greater number, we display it. If num2 is the greater number, then we display it. So what's the function of this program? It collects two numbers from the user, evaluates them, and then displays the larger one. That's it. We didn't have to look at any code to figure that out, and that's how we know that this is a quality flowchart. Now, we're going to build a flowchart from scratch here in just a minute, but before we start, we have to know the requirements for our program. We're going to be building a point-of-sale system for a buffet-style restaurant that calculates an itemized bill for its guests. The buffet includes drinks, and it's $12.95 per person. To get some inspiration for our program, let's take a look at this receipt I have here. Buffet or not, the cost of dining out generally factors in all the same things, right? We have the subtotal, which is the $12.95 to get into the buffet, the tax, and the tip. By adding all of these together, we get our final bill. Our program is going to recreate this receipt for the user. We're going to start our planning party by building out the formulas that we need using a method that I like to call the box model. Now, I came up with this as a programming student, and it has served me really well since, so I'm totally stoked to share it with you. I like this approach because it forces us to get granular, but then it also leaves us with a big picture at the end. So I've started us off with the formula already filled in, so you can kind of see the format. We have the calculation result in one box, and then all of the variables used to calculate that result in their own boxes. I've labeled them with their data types, variable names, and I show how each interacts with the other as part of the formula by putting those mathematical symbols in the spaces in between. Since we're working with money in this program, I decided to make these all doubles. Now, the idea here is that we're reverse engineering our formulas. You start at the end result, which for us is going to be final bill, and then you work your way backwards. We know from our receipt earlier that the final bill is equal to the food cost plus the tip amount plus the tax amount. Now, our top row right here represents that final formula. So the next step is to look at each of these variables and see if we can break them down even further. If you're doing this at home and you're not sure, ask yourself, how is this variable going to get its value? And that's really when the model starts working. So let's start with food cost. If I were dining solo, my food cost would be $12.95 because that's the price of one buffet. But what if I were taking my friends or family out to dinner? The buffet cost for a party of 5 is going to be $64.75. How did I get that number? By taking the cost of entry into the buffet and multiplying it by the number of guests in my party. So our food cost here is starting to sound an awful lot like a formula, don't you think? So let's put an equal sign right here to indicate that coming down. So since I know that this is a formula, I'm going to need to show how we're calculating it. This is basically just an analog variable declaration that we're going to do here. So I'm going to do data types and names. Let's start with our number of guests dining. Since we can't exactly have half or like 3/4 of a person, let's make our number of guests an int. All right. Now, we also need one for the cost of the meal, and that's going to be $12.95, and it's always going to be $12.95. So for this one, not only do we know the value, but it's a constant value. With that $12.95 always being the price, I feel really comfortable making this a constant double. And again, since we know the value of this, we can go ahead and initialize it. Also, since this is a constant, we need to follow our naming conventions for constants. And that is going to be all capital words, with each one being separated by an underscore. Now, how did we say that those two variables were going to interact to give us our food cost? They're going to multiply together. So to indicate that, I'm just going to put my multiplication symbol right here between them. Let's take a look at these two variables. How are they going to get their values? Num guessed is going to be initialized by the user, right? We don't know that information. Meal price is already initialized as a constant, so neither of these can be broken down any further. If they did, you could just put your equal sign wherever you need to, and then just add more boxes as needed. Okay, but since these are good, let's move on to tip amount. So where is that going to get its value? If you think about the process of tipping, how does that go down in real life? Well, first you decide what percent you're going to tip, right? Or the tip rate. As an ex-server, for me, that's usually a given 20%. You take that tip rate, you multiply it by your subtotal, and then that gives you the tip amount. Now, it's really important to distinguish between amount and rate. I see a lot of students get stuck on this. The tip rate is the percent at which you are tipping. The tip amount is the result of that calculation that used the tip rate. Does that make sense? If not, hold tight. We got an example coming up. So if the tip amount is determined by multiplying the tip rate with the subtotal, do we already have a variable that's representing our subtotal? It would be our food cost, right? And I don't need to give it a data type here because we've already declared it. Okay, finally, how are these going to interact? We're going to multiply. So again, we'll just put that interaction symbol right there. All right, perfect. Let's move on to our tax amount. How do you calculate tax on something? It's really similar to tipping, right? You take the rate times the subtotal, and you get your amount. So in this case, instead of a tip rate, we need a tax rate. And of course, we're going to need our subtotal. So I'll go ahead and put that here since we know that. Okay, excellent. Now we also need the tax rate. Here in Ohio, that's 7.5%, but computers, they don't do percentages, they do decimals. So that means that our tax rate is going to need to be a double. Since it's regulated by the government though, I feel pretty comfortable making it a constant double. Okay, and again, we need to follow our naming convention, right? All capital, with each word separated with an underscore. And since I know the value of that, I'll go ahead and put it in. Awesome. Okay. Is there anything else we can do here? Nope. So, these are going to interact again. Let's not forget our symbol there. There we go. Perfect. Okay. Looking good. So, if there's nothing else we can do, we can't break any of these down further, we can now take a look at our big picture. What we're left with now is a nice visual representation of all four formulas that we're going to need in order to show the user their receipt. We've identified all of the variables that we're going to need to do that. We have their data types. We know what we want to name them. It's already planned out. So before we even get coding, we have this information. Now, one last step before we hit the keyboard, flowcharts. So thinking back to our flowchart example, we know that we need to start with the start step. So I just got that out of the way. Now, what's next? Well, if you think about the process of going to a buffet, what's that like? You walk in, what's the first thing you hear? How many people in your party? So it seems reasonable that we might want to make that the first step in our program too. And that aligns with our box model that we did earlier, which revealed to us that we're going to need to know the number of diners before we can do our calculations. Now, do you remember which shape is going to indicate input or output in flowcharts? a parallelogram. So that means we're going to need one right here to indicate that input step. And we're going to use that for our number of guests. Okay, excellent. Now the shape itself indicates the input and the output, and we just write inside here what that particular step is going to do. So this one is going to initialize num guess using cin. What's going to be our next step? Well, if we were at a buffet, we'd probably be being rung up at the register. And we know from our box model that that cashier isn't going to be able to show us our final bill because they're missing a piece of information from us, right? So looking at our variable list, what was the other piece of information we need from the user? Our tip rate, right? So let's go ahead and collect that too. All right, excellent. Personally, I find that collecting all of the inputs at the beginning of your program is the best approach. That way, by the time you get to your calculations, you know that you have everything you need and you're not going to run into any of those like logical order of operation type of errors. Okay. Now, before we continue, is there anything else that we need from the user? Not right now, so we should be able to output the bill then? Well, we can't yet because we haven't calculated it yet. So let's do that first by adding a rectangle for our calculations. Remember? Now with this is a personal choice. If you want, you can put all of those calculations in here for yourself, but for space and time-wise, sometimes I'll just write in here what we're going to be calculating because we have the formulas in our box method. Excellent. So, like I said, if you want to write out the formulas here, you can totally do that, but this gets the idea across pretty well. Okay, moving right along. So, what other functionality do we need in our program? Well, the whole point of this was to show the user their itemized bill, right? And now that we've done the calculations, we're ready to do that with an output. And finally, our final bill as well. All right, excellent. And because this is an output, we're going to get our nice little parallelogram shape. Excellent. All right. If we think back to our flowcharts, do we need anything else to like wrap this up? Well, we need our ending point, right? All of our flowcharts have to have that. So we stop here after we show the user their bill. All right, and boom. That's it. We've got our plan, guys. So we know where we're going, right? We know how we're going to get there. And we know everything that we need along the way in order to make it happen. So one last step, and we're ready to code. Since we're working with math and calculations in this program, just as important as planning, our program itself is putting together test data so that when we run it, we know it's working as intended. So to do this without actually having written our program yet, we're going to execute this flowchart just like we did earlier with the greatest number program. So I'm going to write our test data off to the side here. Now, starting at the top, first we come to CN for number of diners. So let's say that I have 5 people in my party for this test data. All right. Next is going to be our tip rate, which, like I said, as the next server for me, that's going to be 20% or 0.20 in computer terms, right? After we collect that test data from the user, it's calculation time. Got this nice little calculator here, aka my iPhone. And if we type this in here and we do food cost, all right, that's what we're going to calculate first next. is going to be 5 times our meal price, right? Just like we determined in our box method. And that is going to give us $64.75. All right, excellent. Now, I'm going to multiply that by my 0.20 to get my tip amount. So we type into our calculator 0.20, and funny enough, it's going to be $12.95, the cost of our entry. I love that. Okay, perfect. We got a little freaking cool tip amount. Finally, we have our tax amount, and we take that times our food cost at our tax rate, and that is going to give us $4.85. Okay, excellent. And then last but not least, if we add all these up together, like from our box model, right, we get our total, and that's going to give us $82.55. So when we run our program and we put in 0.5, our tip rate, we should get these numbers as the result on our receipt. I hope you found this video very educational in learning not only about the planning process and what that entails, but how to go about it. And I fully expect you to begin using these methods in your own planning process. I'm going to be coding this out in the next video, so stick around. And remember, your ideas are yours and yours alone, and no one can ever bring them to life the way that you could. Go do it. See you next time.